What if I told you that you're being exposed to radiation even while watching this video? From bananas to nuclear meltdowns, radiation is all around us. But what levels are safe and which ones are deadly? Today we'll break down every radiation level, from harmless to horrifying, in just 10 minutes. And at the end, you'll learn exactly how much radiation the heroes of Chernobyl absorbed and why they didn't survive. Stick around, this is going to get intense. Radiation is often associated with danger and disaster, but it's actually a normal part of life. It's the energy emitted from radioactive materials and cosmic rays, and we experience small doses every day. Radiation is measured in sieverts, but for practical purposes, we use millisieverts and microsieverts. 1,000 microsieverts equals 1 millisievert. 1,000 millisieverts equals 1 sievert. Let's break down radiation exposure levels, one step at a time, and explain what they mean for your health. 0.01 microsieverts. Sleeping next to someone. It may surprise you, but sleeping next to someone exposes you to radiation. The body emits radiation from weakly radioactive isotopes like potassium-40 in muscles and tissues. Nightly exposure is approximately 0.01 microsieverts. Despite its disturbing sound, this radiation is harmless. You'd need millions of years of bed sharing to get a deadly dose. This exposure is background radiation, which we're always exposed to. Radiation is natural in our environment and biology, thus it's not necessarily dangerous. 0.1 microsieverts. Eating a banana. Yes, bananas are radioactive, but that's not a reason to stop eating them. A single banana contains a small amount of potassium-40, which emits a tiny dose of radiation, about 0.1 microsieverts. This amount is so low, it's become a reference point for understanding low-level radiation exposure, often referred to as the banana equivalent dose. You'd need to eat millions of bananas at once to experience anything close to dangerous radiation. In fact, our own bodies contain more radiation than a banana. This comparison helps demystify radiation and show how some exposure is completely normal, even tasty. So yes, you're technically exposed to radiation with every bite, but it's harmless and delicious. 10 microsieverts. Dental X-ray. An average dental X-ray emits 10 microsieverts. That seems like a big step from bananas to nighttime, but it's safe. Focused and brief dental X-rays reduce dispersed radiation. Your dentist probably leaves because they do these scans dozens of times a day, not because the dose is harmful. Their exposure builds with time, not yours. Medical radiation is controlled, targeted, and only used when diagnostic benefit exceeds danger. This modest quantity of radiation, less than a short plane flight, keeps your teeth healthy. 50 microsieverts, 5-hour plane flight. When you fly at high altitudes, you're exposed to more cosmic radiation, high-energy particles from space that normally get filtered by Earth's atmosphere. A 5-hour flight, such as New York to Los Angeles, gives you about 50 microsieverts of radiation exposure. It's a higher dose than most people get from everyday life on the ground, but still very low risk. Frequent flyers like pilots and flight attendants accumulate more radiation per year than the average person. And in some countries, they're even classified as radiation workers for this reason. For passengers though, this exposure is perfectly safe. So while the view might be beautiful, now you know, flying also brings you closer to the stars in more ways than one. 100 microsieverts. Chest X-ray. A standard chest X-ray delivers about 100 microsieverts, 0.1 millisieverts of radiation. That's double what you'd get on a cross-country flight and 1,000 times more than a banana, but still very much within safe limits. Chest X-rays are used to diagnose conditions like pneumonia, lung infections, or broken ribs. Although the radiation dose is small, repeated scans over time can contribute to your cumulative lifetime dose, so they're only done when medically necessary. It's worth noting that the natural background radiation we receive from Earth every year is about 2,400 microsieverts, meaning you'd need 24 chest X-rays in a year just to match that. Medical imaging saves lives, and radiation exposure in this context is carefully managed. 1,000 microsieverts, 1 millisievert. Public annual dose limit. Governments around the world set safety guidelines for radiation exposure. For the general public, the maximum recommended dose from non-medical sources is usually 1 millisievert, 1,000 microsieverts per year. This limit is in place to ensure long-term safety, especially for those who might live near nuclear power plants or radiation-emitting equipment. This dose excludes medical imaging and natural background radiation, which are treated separately. If someone exceeds this level consistently year after year, the risk of health complications, especially cancer, could slightly increase. But for most people, reaching this level is rare unless they work in specific industries. It's a reminder that even seemingly small doses, if repeated often, need regulation and respect. 5,000 microsieverts, 5 millisieverts. Worker safety limit. For professionals who work around radiation, like nuclear plant employees, radiologists, or uranium miners, the annual dose limit is higher. Around 5 millisieverts, 5,000 microsieverts. This higher threshold reflects the fact that these individuals are exposed more regularly, and the dose is still considered safe with proper protections like shielding, time limits, and monitoring. Workers wear dosimeters to track how much radiation they've received, and once they approach the limit, they may be rotated out of high exposure zones. While this amount isn't immediately dangerous, long-term exposure can increase cancer risk, which is why radiation workers undergo regular health checks. These limits are backed by decades of scientific research on occupational safety. 10,000 microsieverts, 10 millisieverts. Full-body CT scan. A full-body CT scan emits around 10,000 microsieverts of radiation, a significant increase from an X-ray. CT scans can detect malignancies, traumas, and internal bleeding by showing interior organs and bones in detail. Due to the greater radiation exposure, doctors avoid full-body scans. Since cumulative exposure is a factor, doctors weigh each CT scan carefully. Strong medical radiation is usually utilized precisely. 100,000 microsieverts, 100 millisieverts, increased cancer risk starts. At 100 millisieverts, studies reveal a significant lifetime cancer risk increase. Health consequences become statistically significant at this lower threshold. There are no immediate symptoms, but repeated exposure at this level or greater can increase cancer risk. This dose may be absorbed in some workplaces or nuclear situations. One exposure at this level is harmless, but repeated exposure year after year increases the dangers. 250,000 microsieverts, 250 millisieverts. Emergency worker dose at Chernobyl. Emergency responders at Chernobyl were given up to 250 millisieverts, 250,000 microsieverts of radiation to limit the accident. This is the maximum dose allowed in a life-threatening circumstance where disaster prevention trumps individual safety. Long-term health impacts are probable at this level. Many Chernobyl workers who receive this dose develop malignancies, organ damage, or immune system issues. That cost Chernobyl heroes their lives. Radiation surrounds us, from nature, from technology, and the cosmos. Most of it is harmless. A little radiation is normal and even used to help us diagnose diseases or power cities. But once you cross certain thresholds, the risks grow exponentially. If you enjoyed this breakdown of radiation levels, be sure to like, subscribe, and leave a comment below. Which radiation level surprised you the most? Stay curious, stay safe, and we'll see you in the next one.